All right, the back page. Now we're going to verify it. So this is similar to the, well, what I just did on number 5, except you kind of have two things going on, okay? So you always want to start with the complicated side. Usually complicated means more terms, like more things being added and subtracted than things being multiplied. All right, so that one has one term. That's just a one thing. That one has two things, two terms. So I'm going to start with the right side, actually. Okay, so then I'm going to start with the right side. 1 over cosine of theta minus cosine of theta over 1. Why did I put that as a over 1? Because I know I need a common denominator already. I've done this so many times that there's kind of pattern going on. That is equal to, now I have a common denominator, cosine of theta. My numerator is 1 minus cosine square theta. Oops, blur, blur. There you go. All right, what is 1 minus cosine square theta? That is sine square theta over cosine of theta. Oh, look at that. What does that look like? That looks like the left side. I'm done. Right? So I started from the right side of the equation. I did all the magic using Pythagorean identity. I ended up with the left side. I'm done. That was easy. All right. Now we use that sum difference identity on the previous page and then just plug it in. That's what it is. And then simplify. So that's a A, that's a B. What is sine of A plus B? It's going to be sine of A times sine of A, the pi, times cosine of B, theta, plus, are you with me? Cosine of A, pi times sine of B, theta. So I just plug it into that sum identity, and I'm going to simplify it. I know how to find sine of theta. I know how to find the cosine of theta because that's on the unit circle. All right, so on theta, did I say theta? I meant pi. Pi is on the left side of the unit circle. What's the y value on the left side? 0. So that's a 0. What's the left side at the left? What's the, sorry, it's really late. I'm making this video. Over here, what's the x value? -1. So 0 times anything is 0. So I just get negative sine of theta as an answer. What about this? Sine of pi times cosine of theta minus, this is difference identity, cosine of theta, pi times sine of theta. It's the same thing. That's a 0. That's a -1. But here, it's a -1 times sine of theta, so it's going to be positive sine of theta. Ooh, this is kind of fun, isn't it? What about here? Sum cosine identity equals cosine of pi times cosine of theta. Both are cosine, cosine, but then sines are the opposite. So it's a sum. So you're going to do minus sine pi, sine theta. Cosine of pi was what? -1. Sine of pi was 0, so I got negative cosine of theta, because that thing disappeared. What about here? Cosine of pi, cosine of theta, plus sine of pi, sine of theta. That's a -1, that's a 0, minus cosine of theta. Yep. That's interesting. These are the same. Okay, cool. Next, one more verification. Ooh, this time we might have to use a double angle identity. So quickly review double angle. I'm going to give you this on your test. Sine 2 theta is equal to 2 sine theta cosine theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Or 1 minus 2 sine squared theta. Or 2 cosine squared theta minus 1. Okay, let's go. I see the sine of 2 theta, so I'm going to put that 2 sine theta cosine theta over here. And tangent is what? Let me see over here. Sine over cosine. Are we good so far? Hopefully we are. And now what do we have here? Well, let me clean this up. Okay? I'm going to distribute it. Well, I guess I can't distribute it. It's just a multiplication of one thing. So I'm going to cancel those cosines out. Then I'm left with 2 sine square theta. Why is it 2 sine square theta? Because it's a 2 times sine times sine. 2 sine square theta. That cosine cancels out. Are we good? Alright, so how am I going to go from here to 2 minus 2 cosine square theta? Well, I need to somehow go from sine to cosine, right? Sine squared to cosine squared. Let's see, is there anything I know about the sine squared theta? Do you know anything about it? I don't think it's helpful from here because I don't see any 2 sine squared on the left side, right? So I'm going to go back to what I know. The first Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. We already memorized it. So sine squared theta is 1 minus cosine squared theta. And what if I plug that in over here? Then I got 2, 1 minus cosine squared theta. Right? Which is 2 distributed minus 2 cosine squared theta. I'm done. So did I have to use this double angle identity for the cosine? No, I actually did not use that. I just used that first, the sine double angle identity, and used the first Pythagorean identity to keep going on with that.